take some examples for more clarification for what homogeneous method. Now the first thing you do while solving a first order ordinary differential equation using what your homogeneous method is to make your dy over dx stand alone. Now doing that, we have what solution. We have what xy dy over what dx is equal to x squared plus y squared. The first thing is to make this stand alone. So making your derivative stand alone, we have what dy over what dx is equal to what x squared plus y squared divided by xy. What we did was we just divide throughout this equation with what xy to arrive at this. Now what is the next thing? The next thing is look at your equation. We have y and x as the variable. Now take your dependent variable, call it another variable with what? Your independent variable. Now let's do that. We have our dependent variable to be what? Y. And we say we are taking it to call it another variable. So let's call this is equal to, let's call this v. And what is our independent variable? Multiplied by what? X. That's the next step. Now what is the next thing we have to do? The next thing is using product rule, differentiate what you have here. Now if we do that, we have what? Dy over the x is equal to v plus x dv over dx. This is elementary differentiation, which is what? Product rule. What's the next thing we have to do? We know that dy over dx is equal to v plus x dv over dx. So can we take v plus x dv over dx to anywhere we see dy over dx? Yes. So we can represent dy over dx here as what? V plus x dv over dx. So now if we do that, we have what? Dy over dx to be what? V plus what? X dv over dx. And is equal to what? X squared plus y squared over what? Xy. But we know y to be what? V multiplied by x, that's vx. And we are seeing y here. So anywhere we see y, can we put vx? Yes. So if we do that, we have what? V plus x dv over dx is equal to x squared plus what is y? Vx. So this is Vx all squared divided by x. And what is y? Bracket Vx. So we can simplify this. Simplifying what we have on the right hand side, we are left with what? V plus x dv over what? Dx is equal to x all squared plus this v all square is written as v square x square over, what do we have here? X bracket what? Vx. We can still simplify this further by saying what? V plus what? X dv over what? Dx is equal to, what are we seeing here? We are seeing x squared. So we can bring out x squared, we can factor out x squared. Factoring out x squared, we have what? X squared bracket 1 plus what? V all squared over what? X Vx. What do you think we can do? We can cancel out one of these. And we are left with what? V plus what? X dv over dx is equal to 1 plus v squared over what? What are we left with? Vx. And this is what? All in x. So what do you think we can do? The next thing is to remove this x. And we are left with what? V plus what? X dv over what? Dx is equal to 1 plus v all squared over what? V. But we are seeing v on this side of the equation. Can we take this to this other side? Now, the next thing is taking this v to this side of the equation. We know that the v is having what? A positive sign here. So a positive crossing an equality sign will have what? A negative. So this will be what? X dv over dx is equal to 1 plus what? V all square over v. Taking this to this other side, we have what? Minus what is v? We can say over 1. Now, what is the next thing? We can use LCM to factorize what we have here. Now, using LCM, with the concept of LCM, with the concept of what? LCM, we have this to be what? X dv over what? Dx is equal to 1 plus v all square over v minus v over 1. And what's the LCM? V. So v multiplied by v divided by v, we are left with 1. 1 multiplied by everything we have here, we are left with what? 1 plus what? V all square minus v multiplied by 1, we have v. V times v is what? V all square. So we know that what? X dv over dx is equal to 1 plus what? V all square minus v all square over v. So we can rewrite this equation in this manner. Rewriting it to suit what we have here, we have what? X dv over what? Dx is equal to 1 over v plus v all square over what? V square over v. So this is 0. So this is cancelling out. We are left with what? X dv over what? Dx is equal to 1 over v. Now, what do you think we can do next? We are seeing dv over dx, and we are seeing two variables, x and v. So we can use the concept of what? Separation of variables to simplify this. So using the concept of separation of variables, we can separate these variables by taking what? Let's take x to this other side, and let's keep v on the what? Left hand side. Now doing that, we have this to be what? X dv is equal to, we are cross multiplying, so we have what? V and dv and what? Dx. So the next thing is to divide 2 by x. So we can take this x variable to this other side of the equation. Now taking this x to this other side, we have what? V dv is equal to 1 over x dx. We just divided 2 by what? X. So now what is the next thing? We can integrate this side and we integrate this other side of the equation. Now the next thing is integrating both sides of the equation. We have what? Integral of what? V dv is equal to integral of what? 1 over x dx. We can integrate this side and we can also integrate this side. But we know that if we integrate 1 over x, we have what? Ln x. Applying that concept, this will be what? V raised to the power of 1 plus 1 over 1 plus 1. And this is equal to ln x plus c. Let's simplify this. If we simplify this, this can be written as what? 1 over 2 v all square is equal to ln x plus c. So what do you think? What do you think we can do to this side of the equation? This side of the equation can be written as v all squared over what? 2, and this is equal to ln x plus c. So we can cross multiply. So if you cross multiply, we are left with what? V all squared is equal to 2 ln x plus what? 2c. But we know that what? But we know that what? Y is equal to Vx. That's what we said. So now how can we make V subject of formula that we can substitute what we have here to this place? Now making V subject of formula here, we have what? V to be what? Y over x. So we can substitute y over x to anywhere we see what? V. Doing that, we have what? Y over x all square is equal to what? 2 ln x plus 2c. So we can still simplify this further by saying what? This is equal to y all squared over x all squared is equal to what? 2 ln x plus 2c. You can still simplify this by making y stand alone. Now if we make y stand alone, we are dividing through by, we are cross multiplying. So if we cross multiply, we have what? Y all squared is equal to 2x squared ln x plus what? 2x squared c. So what do you think we can factor out? We can factor out 2x squared because we have 2x squared on both sides. So this can be written as y squared is equal to 2x squared bracket what? Ln x plus what? C. So you solved this equation using what? Your homogeneous method. So we've come to the end of what? Solutions to what? First order ordinary differential equation.